So now we have the reactions of acids and bases, and there are about 4 reactions of acids and bases that you will have to memorize. And you will have to notice them when you see them. So first one, acid and base is always going to give you a salt plus water. Next one, acid plus metal. Now there's only certain types of metals that an acid will react with to give us the salt and the hydrogen. And these are the mazids. We call these the mazid metals. These metals aren't as reactive. Okay, and this is why we can use them to react with the acid to form salt and hydrogen. Mazids, M for magnesium, A for aluminum, Z for zinc, and then I, iron, symbol for iron is Fe, and then tint, which is Sn. Okay, and that's going to give us salt plus hydrogen. Next, we have acid plus a metal carbonate. Okay, anytime you have an acid and metal carbonate, you're always going to be given you're always going to be producing salt, water, and carbon dioxide. Anytime you have a carbonate, carbon dioxide is also produced. Next, you have acid plus metal sulfite. Anytime you have an acid and a metal sulfite, you will always have a salt, sulfur dioxide, and water being produced. Okay, remember sulfite is your polyatomic ion with the symbol. Everybody remembers what the symbol is for the sulfite? SO3. Okay, that's it. Next, we have nitric acid and magnesium. Okay, so which of these categories does it fall under? Acid plus a metal, very good. And we know that that's going to be producing salt and hydrogen. So it's going to be the name of the salts being produced from this. Of course, we look at the ending of the acid, which is NO3. HNO3 tells us that the ending is going to be nitrate. Okay, so you're going to have the name of the metal and then followed by nitrate. That's it. Alright, so you have magnesium nitrate plus water. And of course, this is our formula. If you don't recall how to write formulas, please see me and read the notes. Now we have nitric acid and sodium sulfite. Okay, so we know that this is this group right here, which should give us a salt. What's going to be the name of that salt? Sodium nitrate plus sulfur dioxide plus water. So let's give the name of these products that's going to be formed from the following. So we have sulfuric acid and magnesium oxide, and we know that we need to look and see which category is going to fall under. And here we have, it's going to fall under which category? Acid and base. So acid and base should give us salt and water. So what's going to be the name of our salt? Remember, it takes the ending of the acid. So you're going to have the name of the metal followed by the name of the ending of the acid, which is magnesium sulfate. Very good. Next, you have HCl plus calcium carbonate. All right, first again, the name of the metal followed by the name of the ending of the acid, which is chloride, right? So we have calcium chloride, yes, and then you have carbon dioxide plus water because, right? So acid plus metal carbonate gives you salt, water, and carbon dioxide. That's it. Next, we have the basicity of an acid. So basicity is the number of hydrogen atoms that can be formed by one molecule of the acid. So basicity is just telling us the number of hydrogens that you have present in your acid. That's it. So you could either indicate it by putting a number for the number of hydrogens, or you could use your prefix. All right, mono for 1, di 2, tri 3, tetra 4. So here we have HCl. Here you only have 1 hydrogen, so your basicity is 1 or mono basic. Next you have H2SO4. You have 2 hydrogens, so you have 2 or di-basic. Here you have 3 hydrogens, so you have 3 or tri-basic. That's it.
Okay, and now we are going to start our experiment. So in this beaker, you can see this white powder, and this is zinc oxide. First, we need to pour approximately 50 cm cubed of hydrochloric acid. You will need to warm the hydrochloric acid. Step 1. You are supposed to add excess zinc oxide to your warm acid. As you are adding, you will need to stir. So you would see a residue of zinc oxide at the bottom of your beaker, and you will see a clear solution that is being formed. The clear solution that is formed is zinc chloride solution. Why is there a need to add excess zinc oxide? Reason is because you want to ensure that all the sulfuric acid has been used up and there is no more sulfuric acid left in the beaker. So you have already formed your zinc chloride solution, but is this the end of the experiment? No. Remember, you are supposed to prepare a pure and dry sample of zinc chloride. So how are you going to separate the zinc chloride from the excess zinc oxide? We have to filter. So now we will need to filter out zinc chloride solution. Pour your filter paper into a quarter and place it on your filter funnel. Use a clean beaker and pour your mixture through the filter funnel. Once you are done, you will get a solution of zinc chloride. So, how are you going to obtain dry sample of zinc chloride crystals? So, you will need to do crystallization. Next, you will need to pour the solution onto an evaporating dish and place it over the Bunsen burner. You will need to heat the solution until it becomes saturated. Remember, you cannot evaporate the solution to dryness because zinc chloride is able to decompose under strong heat. Heat till the solution becomes saturated and turn off the flame. You are supposed to allow the solution to cool down and crystals will start to appear.
So when we are forming a salt, like you saw in the video, there are some steps that we have to follow, and those steps are the same no matter which example you're given. So now we have an example here where we have a magnesium strip is being placed into a dilute acid. Okay, so the first thing is that the first step is you are going to add excess magnesium to make sure that all of the acid is neutralized. So you need excess of the magnesium, the metal, or excess of the base so that you can make sure that all of the acid is neutralized. That's the first step. The next step is the solution is going to be filtered. All right, filtration is our next step. Why is the solution filtered? So the solution is going to be filtered to separate the magnesium chloride from the excess magnesium. Okay, and of course, recall the apparatuses that are used for filtration. You have your conical flask, you have your funnel, you have your filter funnel. Inside of your funnel, okay, and then you are going to have your beaker with your solution, with your mixture, sorry, you're going to be pouring it in, and then when you pour it in, the solid will be collected as a residue, and then the liquid will be collected in the conical flask as a filtrate. That is it. So next we are going to, what's going to be the next step? So next we are going to heat the solution, and this is to evaporate most of the solvent. When you heat a solution up, you're going to be evaporating the solvent. Okay, and this is what we want, because we want to be collecting the pure salt. Okay, so we heat the solution. All right, two reasons is to form a saturated solution. And the next one is to increase the rate of the reaction, to make the reaction happen more quickly.